Now, here are the properties we want to understand. You probably remember again, 2 to the 0 is 1. That's what we reviewed. Again, I said by the same reason, 3 to the 0 is 1. Because here you can put 3 here. Everywhere can be 3. So 3 to the 0 is 1. 4 to the 0, you can do the same thing. It's also 1. 100 to the 0, same reason, is 1. Okay. So 2 to the 0 is 1. 3 to the 0 is 1. And the 100 to the 0 is 1. Now, the logarithm is to find out the exponents. That's what we said. So, then 2 to the 1, log base 2 to the 1 is to find out the exponent, which is 0. Okay? Log base 3 to the 1, the exponent is still 0. Log base 100 to the 1, exponent is still 0. Okay? So this tells us log any number, log base any positive number to the 1, you always get 0. Okay? Because any positive number to the 0 is 1. And here we know this one, log base something to the something to the 1 is always 0. If here is 1, you always end up with 0 right here. That's clear. It doesn't matter what the bases are. Okay, that's one thing we got to remember. Another thing is that we know 2 to the first is 2, 3 to the first power is 2, 100 to the first power is 100. Then you know log this base 2 to the 2, you find out the exponent, because the logarithm is to find out the exponent. That's 1. Log base 3 to the 3, then the exponent was 1. Okay? And then this log base 100, this 100 is like this 100. This 100 is like this 100 here. So you find out exponent is 1. This tells us what? If the base is the same with the number here, you always end up with 1. So that's why we have a log base a to the a is always 1. Okay? If here is 99, here is 99, you always end up with 1. That's the second property. Okay. The third property. The third property is here. Before we do that, let's look at this. 3 cubed is 8. Now, using the logarithm is log base 2 to the 8, find out the exponent, which is 3. Logarithm is always to find out the exponent of these 2. Okay? Yeah. So that's 3. Now, look. You know, here is 8. Here is 8. But this 8 equals 2 cubed. So let's replace this 8 by this 8 and the same 8. Or you may say by 2 cubed. So we may write 2 cubed here. So that means log base 2 to the 2 cubed, this is 8, 2 cubed, is 3. Because here is 3. Okay? This tells us what? If the base is the same with the base here, then the exponent, you can bring it down and it crashes all the things just to put the exponent here. This is what it says here. Okay? Here is 2, here is 2, here was a to the x, to the x. Okay? So you see here x are the same, here 3 are the same. Okay, and here's the general proof. Here a is like over 2, x is like over 3, y is like over 8. Now you now write this one in logarithm form, then you will have a log this base a to the y, find out exponent was x. Okay, yeah, all right. Now look, here the y again is like over 8. Here this y is this y, but this y equals a to the x. So we like to replace this y or this y by a to the x. Okay, so you write, instead of y, you write a to the x, because y is a to the x. So here, instead of y, let's put a to the x here. And then you see log base a to the y was a to the x. You see y equals a to the x. It was y, now a to the x equals that. Okay, so you can see if here are the same, 2, a, and then you basically can crash this log a, just write x, as we did here. Okay, that's the property 3. Let's look at the property 4. Property 4, the same reason. 2 cubed is 8 again, and then in order to find out the exponent, you want to write log base 2. Here is the base, here is still the base, just smaller. Log base 2 to the 8 is the exponent 3, so write 3 here. Okay, now 3 equals that. So 3, here is 3, so here is 3. So basically we can replace this 3 by this one, because this one equals 3. Okay, then we will have a 2. Here was 3, you see, 3 here. Because 3 equals that. So we put right here. This was 3. Now, base 2, they are the same. This is the base for the exponential function. This is the base for the exponents, for the logarithm. So 2 to 2 are the same. Drop those things. Just write 8. Drop 2 log base 2. If here are the same, you drop it. Just write 8. And here is the reason. General reason. The same. X is like 3. A is like 2. Y is like 8. So then you write this one in the logarithm form is like that. Okay? So log this base to the y equals the exponent x. Log is to find out the exponent. Okay? Alright. Now, similarly to the above, here is x, here is x, the same x. This x equals that. So we replace this x by this big one. And that will be 2a, here is a, to this big one. So a to this big one. It's like the one here. Okay, so here is the 1. So, and equals y. Okay, it was y here, so you just leave y here. Okay, if a is here, a is here. Only place is here is x, and here is x. We replace this x or this x by this big one, put it over there. Again, this tells us what? The base here for logarithm is the same with the base for exponential. You drop all the things, just write y. But you know, here is y, here is y. You can write here is x, here is x. Okay? So that's why this one we got this one That's the explanation for that. So there are 4 properties. Okay? Yeah.